Hello students. In this session, we will be discussing questions which are based on derivatives and continuity and differentiability. Now, before we proceed, students, there are 2-3 points which I want to discuss because in the normal board syllabus, you might not have come across these points. If you haven't, you should note them down. We'll need it for a few questions. So the first concept that I want you all to know is the types of discontinuities that we have. There are total 3 types of discontinuities that you need to know about. The first one is called a point discontinuity or a removable discontinuity. Point discontinuity basically means that the function is discontinuous only at one point, which means if you look at this graph, at this point, at this particular point, some x coordinate, there is a gap. And that is why it is discontinuous at that point. And at that point, we have this shaded number that is the corresponding value of the function at that point. So that number will also be given, but it will not be a part of this graph. And therefore, we say that it is a discontinuity and it's a removable discontinuity or a point discontinuity. The second one, in this first one, that is the removable discontinuity, students, the left-hand limit will be equal to right-hand limit, but it will not be equal to the value of the function at the second one that you need to know, students, is a jump discontinuity, also called as a non-removable discontinuity. Clearly, there's a gap between the graph. There's a very evident gap. So that is jump discontinuity. In this case, students, LHL, RHL will also not be equal, and they will not be equal to value of the function at A. The next one that we have is infinite discontinuity. It's very evident from the name itself. The graph will tend to infinity. The limit will be not defined, and therefore we say it is infinite discontinuity. So students, I hope you know this. If you didn't know this already, you should note this down. We'll need it for a couple of MCQs. Further, there are 2 more concepts which we need to discuss. Further, students, there are 2 more concepts which we need to discuss before we proceed to the questions. The first one that we have is the graph of log function. I hope you already know this. You have come across this in grade 11th. And if you already know, the graph of log function is a curve something like this. Point, students, on the x-axis is 1 because log of 1 is always 0. So I hope you already know this graph of log function. Other than this, students, you should know derivative of modulus function. Let us discuss this. Let's say if we have this function mod x. Now, do you guys know this rule? Do you recall this rule that mod x can be written as root of x squared? If you know this rule, then you can easily take the derivative. See, modulus function is not differentiable at the turning point. We know that. But we can find the derivative of mod function using this rule that is root of x squared. So if I ask you to take the derivative of mod x, that is as good as taking derivative of root x squared. And we'll do this with chain rule. Now, derivative of root x squared, students. Now, derivative of root x squared is 1 upon 2 root x squared. Into, by chain rule, we'll take derivative of x squared. So, students, derivative of x squared is 2x. So, we get 2x upon 2 root x squared. The 2 gets cancelled. We can write this as x upon mod of x. If you want, you can learn this as a formula also, but these are the steps. I'm sure you know chain rule, and that is why I've shown you the steps. So, derivative of mod x is x upon mod x. You have to keep this in mind, students. And now, let us proceed to the questions. So students, in this first question, question number 9, don't really worry about the options. In the options, there are 4 graphs. But what we will do is we'll normally take the derivative using UV rule of derivative. I'm sure you know the product rule. So over here, when we take the derivative, it is x into derivative log x is 1 by x plus log x into derivative of x is 1. So you'll get the derivative is 1 plus log x. You have to figure out, students, what is the graph of this function. So let us do this. Now we know that 1 plus log x, students, is basically like log x. So the graph is going to be something like this. But we have to now figure out where does it meet the x-axis. So here, students, when it meets the x-axis, y is 0. So do you understand 1 plus log x has to be 0. When we say 1 plus log x is 0, let us solve this. 1, students, we know that log of e is 1. And we know that log of 1 is 0. So I'm replacing everything with log, so we can remove log. So we have log of ex. This is the rule of logarithm, the product rule. And now we can say ex is equal to 1. So x is 1 by e. So this, students, is the answer. X is equal to 1 by e, which means it meets the x-axis at 1 by e. So students, if you look at the options, it matches with option C. I hope you understood this. We'll proceed to the next one. This was question number 9. The next one that we have is question 22. Question 22 is easy, students. I hope you know how to test differentiability from the graph. A function will be not differentiable at those points where there is a sharp turn. If you didn't know this trick, note it down. It will be useful, and 100% there will be 1 or 2 MCQs based on this trick. You have to check differentiability from the graph. This will 100% come. You can take it from me, and we'll test it by the turning points. So it turns at -1, it turns at 0, it turns at 1, and therefore of non-differentiability are these 3 points: -1, 0, and 1. The next question that we have is question 27. 27 is a beautiful question, students. Let us take this. F of x is given to be a function such that f dash x is g. So derivative of f is g, and double derivative of f is minus f. Before we proceed, students, I want you to understand Do you understand double derivative of f means derivative of f dash, which means this is also same as derivative of g. Now students, h of x is given to us. We want h dash. If you're worried, what is this 2024 all about? We'll come to this later. Let's first take the derivative. Now students, you might be thinking we have never taken derivative of such functions, but this is not that difficult. I'll give you a reference example so that it becomes easy for you. If I give you a function log x the whole square, students, do you remember chain rule? And do you know how to take derivative using chain? When we'll take derivative, we'll assume this as x square, students. Derivative x square is 2x, so derivative log x the whole square is 2 log x. And then we have to use chain rule, students, and derivative log x is 1 by x. Similarly, students, in this case, derivative of h, students, see f of x the whole square, derivative of that will become 2f of x. And with chain rule, we'll multiply it with derivative f dash x. Same for g of x the whole square, it will become 2 times g of x, and derivative of g will be g dash. We'll keep solving this, students. Now, do we know what is f dash x in this question? Yes, it is given, it is g of x, so I'll replace it with g of x. This is plus 2 times g of x. Do we know what is g dash, students? G dash is minus f, so this is minus 2g of x into f of x. Do you observe, students? This gets cancelled. We get h dash x is equal to 0. So students, we're getting h dash x is equal to 0. Now you have to think and tell me derivative of which function is 0. I hope you know that derivative of constant function is 0, which means that the function h of x is some constant. Let's say it is some constant k. Now students, once we get this over here, in the first part, they're saying h dash of 2024 is 0. Do you understand, students? Because it's a constant function and the derivative is 0, whatever is the value of x, it doesn't matter, the derivative will always be 0. And therefore, we can say the statement 1 is definitely true. Statement 2, h of 2 is equal to h of half. Now, when we say it's a constant function, whatever is x, the answer is always k. So do you understand h of 2 is also k, h of half is also k. And therefore, h of 2 is equal to h of half. So statement 2 is also true. I hope you understood this question. We'll proceed to the next one. The next question that we have, students, is question number 32. In this question, we have this function f of x equal to x square into sine of 1 by x. They're saying it's continuous. Let us check it. So when we substitute x as 0, we'll get x square is 0 square into sine of 1 by 0. If you're wondering sine of 1 by 0 is not defined, you have to understand 1 by 0 is not defined, which means it is sine of infinity. Now students, infinity means a huge number. But whatever is the number, do you understand? Sine of anything is always between minus 1 and 1. So there will be some answer to this. So it's 0 into some number between minus 1 and 1, which means it is 0, and therefore it's continuous. So this part is definitely true. Let us check the second part, where we are talking about f dash x. For that, we need to find f dash x. Let's go for UV rule and chain rule. So x square into derivative of sine 1 by x, students, will be cos 1 by x into derivative of 1 by x is minus 1 by x square. I've done this in minimum steps. I hope you already know derivatives well enough. If you don't, my best wishes are always with you. My prayers will always be with you. Sine of 1 by x into derivative x square, students, is 2x. This is the final derivative. So the final derivative, when we simplify, is going to be 2x into sine of 1 by x minus cos of 1 by x. We have to check whether it's continuous at x equal to 0, students. Now, do you understand when we substitute x as 0 in this case, students? This is going to be some number between minus 1 and 1. This is also going to be some number between minus 1 and 1. So students, x is 0, so this part becomes 0, minus we have cos of 1 by 0, which means it is some number between minus 1 and 1. Do you understand, students? We will not be 100% sure that the answer is 0. And because we are not 100% sure that the answer is 0, it can be any number between minus 1 and 1. We can say that it is not continuous. So this is also true. Statement 1 is true, students. Statement 2, the derivative of continuous function need not be a continuous function. We just check that. So statement 1 is true, 2 is also true, and 2 is the correct explanation of 1, and therefore it's option A. With that, we complete the sum. Let's proceed to the next one. Question 43. In question 43, students, we have to just take the derivative. So when we take the derivative using chain rule, derivative of sine inverse x, I hope people know the formula. It is 1 upon root of 1 minus x square. One more thing which you should know, x root x, students, when you use the rule of indices, it is x raised to 3 by 2. It is x raised to 1 into x raised to half. When you add 1 and half, that is basically 3 by 2. So when you take the derivative, this will be 1 upon root of 1 minus, we have x raised to 3 by 2, the whole square, into, use chain rule and take the derivative of x raised to 3 by 2. You keep solving this, students. This will be 1 upon root of 1 minus x cube into, this is 3 by 2, x raised to 3 by 2 minus 1 is x raised to half, which is root x. So the assertion is true. The derivative that they have given is correct. Reason they are saying derivative sine inverse x is 1 upon root 1 minus x square. Most students will read this and say that reason is correct, it's the correct explanation, and therefore it's option A. But students, you have to be very careful with minute details. Do you understand that this condition mod x less than equal to 1 is wrong? Because this includes a possibility that mod x is 1, which includes a possibility that x is 1. x can't be 1 in this case. If x is 1, it is 1 upon root of 0, which is not defined, and therefore the reason is incorrect. You have to be careful with minute details, students. We'll proceed to the next one. The next question that we have is 48. Students, is modulus function. I hope you know the graph of modulus function. It's a V-shaped curve. Now, because it meets x-axis at -3, the function is mod of x plus 3. We just discussed in the beginning, students, derivative of mod x is x upon mod x. So derivative of this function mod x plus 3, students, will be x plus 3 upon mod of x plus 3. I know that now you know the steps, so you can just do this on your own and you'll get this answer. Next one, 48 is done. We'll take 74. Question that we have, students, is 74. In 74, we have this f of x. We have to take the derivative. To simplify this, it's actually a type which is inverse trigonometry substitution type. You look at 1 minus x square upon 1 plus x square, students. I hope it has already clicked. If we take x as tan theta, then this is sine inverse 1 minus tan square upon 1 plus tan square, which is cos 2 theta. Now we'll have to convert cos to sine, and we can do that by using this formula that cos theta is sine of 90 minus theta. So it is sine of pi by 2 minus 2 theta. You solve this further, students. This is pi by 2 minus 2 theta. Once you get this, students, once you get this, we know that theta from here is tan inverse x. So students, this is going to be pi by 2 minus 2 times tan inverse x. Now, students, when we say differentiable at x equal to 0, see, to check for differentiability, we'll have to check left-hand derivative, right-hand derivative, which means we need to redefine this function. For left-hand derivative, we'll consider x less than 0. For right-hand derivative, we'll consider x greater than 0. Do you understand, students? For x less than 0, it means the values of x are negative. When we take negative values of x, this tan inverse minus x will become minus tan inverse x. And therefore, this function will be pi by 2 plus 2 tan inverse x. When we check for right-hand derivative, it is going to be pi by 2 minus 2 tan inverse x because it's positive. Now, students, will take the derivative. Derivative of this, the first one, is going to be 2 upon 1 plus x square. And when we substitute x as 0, this is going to be 2. So this is the left-hand derivative. When you take the derivative of the second function, it is minus 2 upon 1 plus x square. When you put x as 0 in this, we'll get minus 2. This is the right-hand derivative. Right-hand derivative is not equal to left-hand derivative, and therefore we can say it is not differentiable. Next, students, once we're done with 74, the next one is 88. 88 is very simple, students. I'll just tell this verbally. You can write it on your own. We have to test the discontinuity. We have just discussed types of discontinuity. This, students, is clearly jump discontinuity, which is also called non-removable discontinuity. So that is exactly what you have to mention over here. Further, we'll proceed. About the reason for this, you'll have to mention left-hand limit is not equal to right-hand limit, which is not equal to value of function, and therefore it is jump or non-removable discontinuity. We'll proceed to question 131. Question 131, students. We're saying it's continuous at x equal to 1. We have to justify. Now, because f-1 exists, students, what is the meaning of f-1 exist? It means that the function is differentiable. The derivative exists at x equal to 1. I hope you know this rule already. If you don't, it's an important rule. You should note it down. If a function is differentiable, if the derivative exists, it is definitely continuous. So we have to mention that. In justify, we just write that it is going to exist. We'll write that because the derivative exists at x equal to 1, therefore the function is continuous at x equal to 1. For the students, because it is continuous, we can say that the left-hand limit is equal to right-hand limit. In the left-hand limit, when we substitute x as 1, students, we will get a plus sine of x as 1. So 1 plus b is equal to, for left-hand limit, when you substitute x as 1, that's 1. This, students, is the relation between a and b. Now they're asking us to find f-x. F-x in this case, students, derivative of a is 0. Derivative of sine inverse, this is inverse by the way, derivative of sine inverse is going to be 1 upon root of 1 minus x square. So that is x plus b the whole square. Use chain rule into derivative of x plus b is simply 1. This is f-x for x greater than equal to 1. And derivative of x is 1 for x less than 1. Now, students, because the function is differentiable, we can replace x with 1 in this case and solve. When you replace x with 1 over here, we will get 1 upon root of 1 minus 1 plus b the whole square is equal to 1. The left-hand derivative is equal to right-hand derivative. You keep solving this, students. I'll square both sides and multiply. We will get 1 minus 1 plus b the whole square. This one is getting cancelled, students. We are left with 1 plus b the whole square is equal to 0, which means 1 plus b is 0. And from here, we get b is minus 1. Once you get b is minus 1, you can substitute it over here. You will get a plus sine inverse 0, which is 0. So a is 1. So these are the values of a and b. A is 1, b is minus 1. With that, we complete this session, students. We are done with all questions of derivatives and continuity differentiability. You have to practice similar questions, students. Especially the graph-based questions from continuity differentiability can come. Especially the graph-based question students from continuity and differentiability will come as an MCQ. So be prepared for that. Thank you.